DMNX uses access profiles to authenticate when it discovers a device. The access profiles contain two different types of authentication. The first thing is the SNMP profile. After pinging the device or contacting it using its host name, DMNX sends an SNMP query to determine if the device has a printer MIB. DMNX interrogates the IP address or host name with an SNMP query. If the device responds appropriately, indicating that it has a printer MIB, it sends a more thorough interrogation with SNMP account login information. That account accesses the device for deep dive information, such as whether it's a third-party device, in which it can get vendor name, serial number, some counter information, or whether it's a RICO device, in which it can get much more information, which you can see in the Device Properties window. This is true for both SNMP v1 and 2 and SNMP v3. The second thing to authenticate is the administrator access account. DMNX tries to log into the device's Web Image Monitor page as administrator. This is because some of the settings that DMNX can change require administrator access. Examples of this are firmware updates, remote device configuration, updating the address book, and updating Java and embedded applications. Both of these authentications are recorded into the SQL database during discovery. You can change these variables using standard device preferences templates. When you have multiple DMNX profiles, you can change the order in which it tries to authenticate using the different profiles. The reason that this is important is that when you are at a large customer that has sites all over the globe, those regional sites might each have their own SNMP profiles and/or device administrator access accounts. So how would DMNX handle this? If you are running a discovery that spans the entire wide area network, you have to plan for the fact that some of the discovered devices might use one of those different SNMP and device access accounts. So when you are configuring a discovery task, DMNX allows for not only the ability to create the different profiles, but also to prioritize the order in which they are checked. It's important to get the priority right in the order that they will be executed, because, for example, if you have 6 SNMP accounts and it's the last one that will be successful, you have significantly increased your discovery time. This is because it takes a few seconds to time out. So for each discovered device, DMNX will try each of the 5 other authentication profiles before being successful. There are a couple ways to configure this. The first way, which we will show you here, will create a single discovery task with several SNMP profiles and several device administrator profiles. Go to Discovery and Polling, Network Search, and select a new discovery task. Give the task a name and a description. For training purposes, we will use a name of United States and a description of WAN discovery task. Next, set the discovery range and the subnet mask. Select Save. Select the Access Accounts tab and the SNMP Access tab. Notice that there are several SNMP access account profiles listed under the Not Assigned section. Select each of them and arrow them up to the top Assigned Account section. Once they are in the Assigned Account section, the tasks can be prioritized by selecting the one you need at the top and selecting the up arrow to move it up in the list. Notice that each account is listed to time out after 3,000 milliseconds. If you have a location that has poor bandwidth, you might need to alter this setting. To do so, go back to the list of SNMP access profiles and select the profile to be changed. In our example, we are using the Chicago profile and doubling the timeout to 6,000 milliseconds. When we return to the discovery setting, notice that the timeout has been changed for the Chicago profile. Once all of the account profiles are in position, go to the Device Administrator Account tab. Repeat the same process by moving the unassigned items to the assigned list, prioritize them, and save the network search. Another way to accomplish this configuration is to create individual network search tasks for each location, using limited IP address ranges, and to assign the appropriate authentication profile for each. This requires additional work up front, but it may speed up the discovery process, as each task will not have to cycle between all of the authentication profiles. One disadvantage of this process is that it may not catch all devices, since it is not using a full range of network IP addresses. One or two subnets may fall through the cracks if the administrator forgets to add them. A wide area network-wide discovery ensures that all devices will be discovered, even if that discovery task takes longer. If you are performing SDKJ updates, you must configure not only the device administrator and the SNMP credentials, but the SDKJ account login credentials as well. This is configured in the same place as the other two. First, in System Information, enable the checkbox for SDKJ platform installed in the devices. When installing the SDKJ platform template, there are two sources. You can download the information from the RICO software server, or you can use a file from the local repository. When you create a task to assign these templates, you have the option of checking the current platform against the latest package available on the RICO software server or in the local file, or you can apply the template without checking for the currently installed version. In cases where the SDKJ platform update is applied in a task, but the Java platform selected is not compatible with the RICO server, the error unsupported device will appear in the task log. Next, in Discovery and Polling, Access Profiles, select SDKJ and either update the default profile with the appropriate login credentials or create a new profile with login credentials. Last, in Discovery and Polling, Network Search, confirm that the SDKJ platform access includes the correct profile or profiles.